So, yeah, good afternoon, everyone. This afternoon I'll be talking on the Sandhills getting greener. I'm Paul Akpejeluh. I'm a first-year master's student at the University of Nebraska-Lincoln. I'm working with Dr. Daniel Uden, and I'll be sharing with us a couple of preliminary results I'm having on my master's thesis and a bit of the work we're also doing in Kenya. Because although I know the conference is actually centered towards Nebraska rangeland, but we're doing a couple of work in Nebraska, and just kind of give us like a quick rundown over like this cross-continental comparison between Nebraska rangeland and what's going on in East Africa and Kenya. It's basically under the general theme of desertification, which is this global vegetation challenge that occurs everywhere. And so what I think Dylan did talk about, where we have this transition from our rangelands into woody lands. So we also have this one going on in the Sandhills, the transition from our rangelands, grasslands into bare grounds. And so that's kind of what we'll be talking about today. And this is basically under, so I'm just having a couple of issues with my slide. Yeah. When we look at the conversion of our rangelands into bare grounds, it's basically under the idea of regime shift, or what we call ecological state transition, which is after, if you see this ball design here, which is after a series of disturbance over years. What we have is that a stable ecosystem would actually tilt past this threshold, ecological threshold, and then tilt into another alternative regime. And so we have rangelands changing into woody lands, or rangeland changing into bare ground, which I'll be talking about. And the reason this is actually an issue is because most of these are grasslands. They actually provide these critical ecosystem goods and services. And so when they change from grassland into bare ground, we tend to lose these ecosystem goods and services. And also, a couple of speakers have talked about several endangered plants and animal species that we are losing. And so the conversion of our rangelands into bare grounds would actually lead to loss of this grassland. So we're using remote sensing because it's like a cross-continental project, and so remote sensing actually affords us this flexibility to actually look at monitoring these grasslands in Africa and also here in Nebraska. And so we have that flexibility with remote sensing. And another key cool fact with remote sensing is that we can also look at it, not just multiple locations, but also look at these changes over time. And so with historical data set, we could compare time series changes that have actually occurred from time past into what we currently see in our landscape currently. And so this why we use remote sensing. And the ability for remote sensing actually spans from the fact that landscape, different land features on the Earth surface, they actually have their unique spectral signature. If you see this picture here, the brown one is for soil, the green spectral curve is for vegetation, the blue one is for water. So each of them, they have their own unique spectral signature. Vegetation specifically, we'll be talking about the grasslands. They reflect the near infrared radiation more than any other one, more than soil, more than water, and they also absorb the red radiation more than the most with soil and water as well. And so because of this unique feature of vegetation, we will be using NDVI as our metric for monitoring this vegetation greenness over time. And although for this research, we're currently also looking at SVI, Standard Vegetation Index. We are looking at EVI, Enhanced Vegetation Index, but I just wanted to kind of talk on this one because of limited time and all that. So NDVI value basically kind of works to normalize the difference between the near infrared and the red bands. And so the value range from the -1 to +1, and the more positive values you get means the denser the vegetation. So towards +1, we'll have more dense vegetation like woody lands and forest vegetation, while towards the -1 we would have very sparse vegetation, water, background surfaces, and so we'll be talking about this in a short while. And for our monitoring tools, we are using the rangeland analysis platform and the Google Earth Engine IDE. Currently, we're also using other tools, but I just wanted to talk about these two. And both of them are actually this web-based platform, cool tools. The rangeland analysis platform is actually specifically for Western US rangeland. So we could use it to monitor annual forbs and grass cover, perennial forbs and grass cover, shrub cover, tree cover, background. And so it gives us this access while we could also do all sorts of spatial analysis with the Google Earth Engine. So these are tools we are currently using. Down to my main discussion for today is this issue of backgrounds coming out in form of blowouts in the Sandhills, which I guess we've all basically seen. The blowouts are these conical depressions. We see these conical-like depressions where this high rushing wind literally blows out a portion of the landscape, and so we have this sandy depression coming out of them. And the major challenge for landowners is that this is not actually static. It actually, the blowouts actually move. And so what we see is that over time, they've been transiting over time. And so you don't want this expanding into other portions of the landscape to kind of reduce the land. And even though the blowouts, one also key thing is that there are several species that are blowout dependent, like the blowout penstemon is actually a plant species that actually needs is only available in the blowouts. And so while it's important for such species, we also don't want to see it expanding in our landscape. And like I said, the blowout actually has been transiting over time. I got this cool picture from 1912. So this was over 100 years ago by Raymond J. Poole. It was published in the Popular Science magazine far back in 1912, over 100 years ago. And so the blowouts didn't really start yesterday. They've actually been transiting over time. And so the need for monitoring this blowout becomes very important. So that's what we are currently looking at. Several works have been done. I'll just be going through like a couple of works that have been done, looking at blowout background encroachment in the sandy, looking at what we are doing as well, and also the work in Kenya. So this work was done by Jeff Hartman in 2015. They looked at, this is the UNL Bata Brothers Ranch. And they looked at, they had a grassland destabilization experiment to kind of look at the sand dunes destabilization of the sand dunes, to look whether it's actually vulnerable to destabilization. And while this one was done by Jack Attibon, and so there have been several discussions going on about the vulnerability of the sand dunes to depression. And so the 2012 drought and wildfire that occurred in Nebraska actually. So we have this existing blowout then, and landscape that was actually burned and during the drought period. So the kind of fear then was that when such disturbance, large scale disturbance actually occur on the landscape, what we'll see will be this existing blowout actually expanding and extending towards the landscape. And so we'll see sand drifting all over the landscape. But Jack did show that after a couple of years, the grassland actually did recover. And as long as, so they found out that as long as the below ground biomass was not actually destroyed, that over a couple of years, the grassland would actually recover. So this was actually kind of showing us the resilience of the Sandhills towards destabilization, and a couple of what we'll be talking about. So this work was done by Matthew Jones, Director Brady Allred, and a couple of others, and it just kind of looks at it from a regional perspective. And this was, so they had several plant functional groups for annuals, but I just wanted to look at perennial grasses and forbs in comparison with backgrounds in Western US rangeland. And the blue pixel shows us the increasing trend, while the red pixel shows us decreasing trend. And so for perennial grasses and forbs, the blue pixel, we could see here that towards the northern Great Plains, we could see this increasing trend in perennial grasses over time. This was 1999 to 2018, so about 20 years. We saw this general increase in perennial grass cover. Why for the bare ground, you also saw a corresponding decrease in bare ground, so which actually makes sense as we are seeing this corresponding increase in perennial grasses. That would actually support this decrease in bare ground as well. And if you look closely towards the Nebraska, you could see the Sandhills, which is not as the increase is not as very detailed as other portions of the northern Great Plains, but you could also see the red decrease in bare ground over time, as well as the blue portion as well, showing the increase in perennial grasses over time. And this was done by Dillon, who talked some minutes ago, and we looked at another kind of transition, the woody land encroachment in the Sandhills. So they did a couple of these in several BULs in biological unique landscape in Nebraska. But I just wanted to point out the one at the Medio Niobrara River Valley, which is also my study area as well. I'll be talking about in a few minutes from now. They looked at this BL, and the red portion actually shows increasing woody plants, woody cover, while the blue pixel, the blue color, shows decreasing woody cover. And so we see towards, if you look closely, you see this red polygon. So we see this decreasing trend in woody cover in this polygon, and this is actually a wildfire perimeter. So they used wildfire to actually decrease woody plant extension in that region. So to kind of go over what I said we're doing in Kenya and kind of relate it back to what's going on in Nebraska Sandhills. So in Kenya, they have these bomas, they call them bomas, which are basically these acacia trees that are cut, then they are used to monitor, they are cut, then they are used to create this round-like structures, and so they camp their animals there. Then during the day they go out for grazing, then at night they come back and camp. And so it's usually water dependent, so they are usually built around where they have water. So most times when the place gets dry, they have this very arid climate in that part of Africa. And so what happens is that once the region gets dry, they have to relocate. And so over time, what you see are these several bomas that have been created all over the landscape. So this is just like a satellite view from Landsat, about 30-meter resolution, while this is a drone view of the bomas. And so what we're doing in Kenya is basically to kind of monitor vegetation indices with respect to precipitation indices, and kind of look at the relationship between the vegetation that climate is having on the vegetation in the region. And some interesting things we're actually finding in this region is that what we would not naturally expect is that as precipitation was increasing, the greenness, the vegetative greenness in the area would actually increase, which would make sense, but it's kind of going the opposite direction. And so the time period they had above and average rainfall did not actually correspond to a period where they had increasing NDVI, which was measure of vegetation greenness, and the time period when they had below average rainfall did not actually correspond to the time when they had decreasing NDVI. And so the question would be, what's if we don't see this positive relationship between NDVI and precipitation climate, so what other factors could be at play here? So and one of them we're looking at is grazing. And so we're kind of comparing between these boma locations and other protected areas to kind of see the implications of grazing management practices on vegetation and climate interactions. And one cool thing they also have there is this bimodal precipitation pattern in Kenya, which is quite different from the unimodal pattern we see in Nebraska. So towards the beginning of the year, you see this increasing rainfall period, while towards the ending of the year, you also see another high one, unlike the unimodal pattern that we do see in Nebraska. So back to Nebraska, back to the Sandhills. So my study region here is the Middle Niobrara BUL, and so we'll also be looking at this brown shaded portion, which is the Nature Conservancy Valley Preserve. So we'd also be looking at these two regions, kind of comparing NDVI, the long-term, short-term, and interannual NDVI and precipitation relationship in both regions to see the climate interactions with vegetation, and if there's this positive or negative relationship like we're seeing in Kenya, and if the relationship is not actually positive, what could be? So wanted to compare that in the entire BUL and that of this protected area to kind of see like the differences. So we did this with the rangeland analysis platform, and we just had this cool chart. The blue chart lines here is for perennial grass cover. The red one are for bare ground, while the green are for annual precipitation that was measured in inches. And so we could see in the Middle Niobrara BUL, we could see this decreasing trend in vegetation cover in grassland and perennial grass cover around 2012 when the drought occurred. And so it actually makes sense. And we saw this increasing bare ground transition as well, which was similar to what we had in the Valley Preserve, and also similar to what the Matthew Jones paper I showed earlier was talking about. And yeah, we just went to chart. So we did this with Google Earth Engine and a long-term NDVI, a long-term precipitation time series analysis. So we did this with Google Earth Engine, and we charted precipitation over time. And the precipitation was from CHEP's data set, the Climate Hazard Group Infrared Precipitation Station data. So it's measured in millimeter per pentad. So it's taken every 5-day period. So we charted it for over 1981 down to 2020, which was over 35-year time period, to see the trend of precipitation. And you could see clearly the 2012 period, though they had this very little rainfall. And like I've been saying, we also looked at NDVI and precipitation patterns. So towards the early part of the year, we did this 35-year time period time series to look at NDVI and precipitation relationship. So towards the start of the early parts of the year, we had this gradual increasing trend in NDVI, while as the year went on, as we came to more recent years, we saw that the trend, although still also increasing, but actually had a more slower decrease in its increase as well. So we did so this was the precipitation chart we also did for the 2012 Nebraska drought period, and we saw the very little rainfall period also measured in millimeter per petard as well. We saw the very little rainfall period in this thing, and this was for NDVI, and we saw that, like I said, the unimodal precipitation pattern. So this one was showing us when we charted for precipitation, this had similar charts to that of precipitation as well. So we had increasing NDVI as well as increasing precipitation. So it was more or less like a positive relationship between NDVI and precipitation in the region. And we also classified NDVI and precipitation in the Middle Niobrara BUL as well as the Valley Preserve. So this was in 1985, 2000 and 2020, just kind of to see the what has happened before, what happened, and kind of the more recent trend. So this we classified it into 5 classes. The very green part, which was not very obvious, are actually points of because of my zoom level, they're actually points of woody plants and trees. So the yellow part, which is more obvious from here, is actually the sparse vegetation, while the brown color pixel that we see here for the bare grounds. And so, like I said, we wanted to see the bare ground transition over time to see whether grass cover has actually been increasing or decreasing over the Middle Niobrara BUL. So we saw that from 1985 to 2000, about 15 years, it was actually decreasing, and the more we got to more recent years, it has actually really decreased, although we still have some visible pixel over here, but not really visible from my zoom level. And so we also did the same thing for the for the Valley Preserve, which is also a protected area, to kind of see if to see the relationship between climate, vegetation, as well as what grazing management practice had, whether it had implications like we saw in Kenya as well. So, so we also see this kind of similar trend where precipitation was increasing, bare ground was decreasing, So over the years, the bare ground cover has actually also decreased quite a lot in the protected area. And so this was the NDVI precipitation, kind of wanted to chart correlation over time for both time periods. So this was from year 2000 down to 2020. And so we see the similar increasing trend in NDVI and similar increasing trend in NDVI and precipitation in both regions.
You can close sometime, Paul.
Yeah, so we're rounding off now. Which was also quite similar in what we see in the Nebraska Valley Preserve as well. So in conclusion, the stability of sand dunes is influenced by climate, by fire, by grazing, and other management practices. And so with cloud computing tools, we actually have the ability to kind of monitor this transition over time. And the next step we're actually looking at is kind of to map NDVI and precipitation relationship over time. And so to see like the NDVI classification we did, to see portions of the landscape where they had increasing NDVI and precipitation relationship, and just map that over time. So using Mankendo's test. Yeah, so thank you.